All right, so at Black Hat, we did a 150-minute presentation called Tactical Exploitation. At DEF CON, we're going to do a 40-minute presentation called Tactical Exploitation. You may want to record it and play it back slowly. We tried not to sacrifice content, so we'll see how well we can do this. Worst case, after this, we're not going to do any Q&A here. We're going to go to the track 1 Q&A room, and we can actually do additional demos there if anyone's interested. So first thing, this talk is called Tactical Exploitation. It's about a different way to do pen testing, a different way to look at your targets. Personally, I've been kind of sick of how folks who are new to the security industry are getting started by running Nessus and following that up with Core Impact or Metasploit, and that's all they do. And this talk is really supposed to be a way to look at those other ways to get in, other ways to get shells, other ways to compromise a network that don't depend on an existing vulnerability or a specific tool. So first off, who are we? My name is H.D. Moore. I'm Director of Security Research at a company called Breaking Point Systems. We do network test equipment, and it's not really that interesting to most of the folks here. I'm also the founder of the Metasploit project and one of the core developers.
I'm Val Smith. I've been contributing to the Metasploit project for several years, and I'm one of the founders of Offensive Computing. So
why you should care? This talks about a different approach to owning stuff. So instead of looking for a specific vulnerability, a new 0-day, a new something, basically looking at what you actually have and just using the stuff you already have to get a shell. All sorts of new fun new techniques, new tools, kind of rehashing some really old stuff that still works really well, and it's all real world tested and mother approved. So first off, the first section of this is going to be about target profiling, some discovery tools you may or may not know about, hopefully some new stuff in there. One of the fun demos we're going to do today is actually first published in I think 1999 or 2001, and the difference is I can still get a shell on an XP-SP2 box with it, so I don't care. So when you see things like that that are kind of old research, the point is now they're really feasible, they're really easy to do, and we've automated the crap out of it. The second section of this is all about getting remote access. We're going to cover things like trust relationships, fun MTLM stuff, all kinds of cool stuff. I'm sorry.
Okay, so basically we're going to talk about the tactical approach. Vulnerabilities are transient. They come and go. You'll have O-Day today, tomorrow it'll be patched. So really, you need a long-term approach to breaking into computers. Target the applications, the things that people use. Target the processes, the things that they have running on their servers. Not necessarily big commercial products, things they write in-house. Especially target the people. The people are a big part of this. Trusts, networks trust each other, people trust each other, accounts trust each other. So target those things and you will gain access. So, let me do this one.
Sorry, we're still trying to figure out how, after we chopped up our content, how to split it up. So give us some leeway. So first off, crackers are opportunists. They're going to break into whatever they can. If you have a job breaking into a bank, and they say, we can test this server, and this server, but not this server, and not this time, well, that's your restriction. It's not the restriction a real attacker is going to have. So make sure when you're talking to a client about a possible engagement, you make those things clear that anything they restrict you from doing is probably the most severe thing that is the point of attack. I can't tell you the number of times we've done a pen test and someone has said, well, you can test everything but a domain controller. It's like, the only reason I'm doing this pen test is to crack your domain controller. So keep those things in mind. Like, you really want to make sure your client or whoever you're doing your pen test or attack against understands that whenever they put a restriction on your scope, they're doing themselves a disservice. And anything you don't test, someone else is going to test whether they want to or not. So hacking's really not about exploits. It's all about the data, but it's all about the data, but it's not about getting root or getting admin or anything else.
Sure. So, see what you can go after. Can you go after corporate information, design information, things that the company doesn't want you to have? I mean, getting root on a box is cool, but what can you do with that? A lot of times having access as a regular user is actually more important than being root. They're logged less, they're watched less, you can move around the network. Hacking is using what you have at hand, not necessarily exploits, to gain further access to more hosts and to more data. Whether it's passwords, trust relationships, hijacking services, authentication systems, and we'll go into detail on all these different things. Security is primarily a people problem. People write your software, people introduce your bugs, people screw up and double click on the viruses that you send them, people skew your network. So identify the meatware first.
Sure, I'll grab this. So there's lots of great tools for finding out who actually works in an organization or what they do or getting a list of email addresses. There's tons of great tools for this stuff. One that I want to focus on today, just because it's so freaking awesome and not many people know about it, is a tool called Evolution from Paterva.com. Does anyone here actually use Evolution? Wow, okay, so like one or two folks. Great. Well, this is definitely a badass tool you should be using. So what Paterva does is you give it a piece of information, like a name, an address, an email address, something like that. It'll go through and find everything related to that using about 40 or 50 different backends. It'll crawl Facebook, trying to find pictures of you. It'll crawl, Flickr. It'll go through your LinkedIn account and try to find associations. It'll go through a company name related to your LinkedIn account and gives you this really cool graph-like interface you can use to basically dig into more information about a given person, product, domain, etc. So all these types of tools, what they give us is the full name, the username, the email address, employment history, phone numbers, list of personal websites. There's a huge amount of information you can grab from these tools. Here's an example of actually running the Evolution GUI tool against HD-More, which you find like my email address, you find websites I've been mentioned on, you can actually get my phone number out of it. And at this point, if I decided to pick on, double-click the hdm@metasploit.com link here, it would actually go through and find every other email address at metasploit.com, or find any other place where that address has been referenced. So where have I done posting? Where have I, any other place my address has shown up in a listing? Same thing down here, Gmail, the browser fund site, you'll find any site that links to that site, and so on.
Okay, so this is basically like a little case study of how important this information is when you're breaking into networks. A lot of people tend to focus on an IP address, a range of IP addresses, but this information really helps you out. In one example, we started with a company that we were going after, that we knew we wanted to target, and a specific type of information at this company, what the job descriptions were. So we started searching the internet for what people are likely to be working on the information or the work that we really want to target. So in this particular case, we found an online personnel directory. We found people with access to the data that we wanted. A lot of times you can find people's resumes out on their sites. They don't know it's linked. They have it in some hidden directory. But that's good information because it tells you they're working on the systems that you want to go after. In a lot of big corporations or large targets, the email address is the username. So, if their email address is joe@whatever.com, they're going to be logging in as Joe. So target that. In this particular example, we had a guy, we'll call him Joe Targetstein, and he was a lead engineer in a big semiconductor department of a company. We found his email address in the online directory. Old news groups gave us a hint as to what his host name might be. So what do we have? I mean, just searching the internet about a person, we now have a username to target, a host name to target, to go after a very specific information that we want to get, not just get root on a random machine.
All right, so we're actually going to be flying through a lot of this material pretty quick. The way it's kind of structured is we're going to talk about different ways to do discovery. We start with the people, going to the networks, the applications, and so on. And about halfway in, we actually flip to actually doing exploits against hosts. So if this sounds like kind of boring remedial stuff, well, yes, but it's important, and we're going to go into why it's important as we go through this process. The next thing we're going to talk about is network discovery, basically identifying every asset that your target has. So if you know that a bank, you know what their domain name is, and you're trying to do a pen test against that site, they may not be the only server they have, may not be the only place they've hosted a resource. You need to go through and find every MX record against every single host. You need to find out what internal networks they have, what branch networks they have, how are the branch networks connected, what outsourced services do they run, do they have an outsourced spam gateway. All these things are critical to your asset and critical to breaking in, and need to know how to find them. There's a lot of really good tools for this. There's things like, VOS brute forcers, there's mmap, the different open source resource tools. But we're going to go and skip ahead to some things that most folks probably haven't heard of before. So lots of fun things. The neat things about these services is that they're services. They go through someone else's server to bring you information about your target. So in other words, the target has no idea that you're profiling them or pulling information about them at all. Val, do you want to cover the first two?
All right, that mic sucks. So the idea behind this is to use other people's services to do your attacks. What people currently do is they'll attack an address or they'll attack a network from wherever their lab is. So your target is going to get things in their logs to let them know that this kind of stuff's going on. There's a lot of good websites out there like Central Ops, Digital Point. What these sites do is provide the services that you would normally do by hand off their web page, which means that attacks are coming from their networks. Central Ops will give you like a dossier on your target. domain name mapped to IP address, who owns the network, who owns the domain name, even in some cases what ports are open for a certain subset of standard ports. A lot of good information. Digital Point is a great site because it'll do DNS zone transfers. Super old thing that still works today. I use it all the time. So this is good intelligence gathering for your targets, and it's about building up a picture of what to attack. Let me see some more.
All right, this works, great. So the other two sites I'm going to talk about are domaintools.com and perturber.com. A minute ago, I showed you the Perturba GUI interface. So if you download their product, install it, try it, you'll see this neat little graph interface. However, they've got a web demo as well, and the web demo basically runs all these same tests, but coming from their server, not yours. The next one we'll talk about is Domain Tools. And Domain Tools used to be called Whois.se. Has anyone actually used that service before? Excellent. All right, great. Well, there's a really cool feature of Domain Tools, and what that is anytime a domain is registered, they get that domain sent to them by the registrars. And they say, okay, this new domain exists, so we're going to reverse DNS that domain, find out what it resolves to, put it into a big-ass database, and later on we're going to allow someone to query and say, okay, what domains exist on a given IP address? In other words, they keep track of every domain on the freaking internet and give you a list of what vhosts are on a given IP address for you. So some fun examples of that. If you run Domain Tools, this reverse IP thing against defcon.org, you find a great list of all these cool different domains running on the same server. You've got Dark Tangent, you've got defcon.net, and defcon.net's interesting because it resolves to more than one IP address. And we'll go into that a little bit later. You got Hacker Jeopardy, and this thing called Hacker Poetry. Has that been announced by anybody? Because I'm going to put a bullet through my head if I have to listen to any Hacker Poetry. It sounds horrible. And just in case you don't know who the Dark Tangent is, you can now go to thedarktangent.com.net.org. So with defcon.net, I mentioned before that it resolves to two different IPs. So if this is the first IP. If you look at the second IP, we go on to the next slide. And here you can actually see that defcon.net is actually the same server in one case as zeroday.com, zeroday.net, securityzen.com, and zeroday.com with a Z. And there's actually a bunch of personal domains I ripped out for Jeff and Ping's sake. There's like Republic of Ping, all these other great ones. So I pulled those ones out, but they're entertaining to look at least. So if you're ever mad that someone else stole zeroday.com, they're not using it, you can bitch at Jeff. But apparently he's had it for like 10 years. He's had it so long that when he first registered the domain, all the Wares kids were like pestering him, trying to say, hey, can I use that for my Wares stuff? Because, Zeroday used to be about Wares. And now Zeroday is about security stuff. So he has all these, security guys saying, hey, can you use that for my security stuff? So I suggested that we use it for kind of like a power sellers for Zero Bay. So if you're a real power seller for your Zeroday, you can actually get an email address at odata.com, and hopefully Jeff will go with that. So what does this get us? These different sites will do proxy DNS probes, do zone transfers. You can list a virtual host for every IP address. You can do port scans, trace routes, all kinds of great stuff. And the best thing is none of it comes from your system. So even if the client says, hey, you're not allowed to test this, or hey, I only want you to do tests against this IP, you're not testing it, they are. So I'm just saying, you may not be in breach of your agreement, but it works. Next slide, please. So those are kind of the passive, kind of indirect discovery techniques. The next thing we're talking about is active discovery. And we're still talking about network discovery. How do we figure out what IPs they use, what networks they use, where they come from, how they browse the web from, what's their NAT gateway, all those types of information. One of my favorite techniques for this is just doing SMTP bounces. Just about anybody with an Exchange server configured will bounce an email back out from their Exchange server with usually the internal headers, internal host names, internal version numbers of Exchange inside the headers of that email. So don't be scared just to email your target. I mean, they get so much freaking spam each day that if you send them a jumbled email, they're not going to know the difference. It's great. So abuse that. Sorry, go back. Also, there's things like definitely brute force vhosts. So definitely, even though Whois.se or Domain Tools doesn't show what host names are on a given IP address, try connecting to it and just sending a host header of intranet or www or admin, things like that. You'll find all kinds of great cases where the user had misconfigured their server and actually hosts their intranet site on the same physical IP, but assume that the DNS will do the work of hiding that from the external users. And finally, you can actually just watch outbound DNS traffic. If you send someone an email from a domain where you control the resolver for it, so let's say you create a fake subdomain called mysubdomain.metasploit.com. You send them an email from Bob at mysubdomain.metasploit.com, or sorry, Bob.another subdomain.that subdomain.metasploit.com. When that mail server tries to bounce it back to them, it's going to do DNS lookups for that. Through that technique, you can figure out what DNS server and not only what type of DNS server, but where that DNS server is located inside their internal network by looking at those queries coming in. So if they're using an external server for all resolution, you'll see that because you'll get queries from external IP address that's not related to their NAT gateway. If it's using an internal DNS server, like Microsoft DNS, something like that, you'll be able to not only find out that they're coming through the NAT gateway, but you'll also be able to realize what type of server it is based on the port sequence and the XID sequence. So here's an example of messing with RSA, because RSA is awesome. And we all think RSA is great for security, right? RSA security. I mean, hell, they got security in their name. All right, so RSA is nice because they run it a bunch of different mail server products inside. And if you email just a random unknown user at their domain, it'll bounce back and it'll actually have the internal IP address of their mail relay, not even in the headers, in the freaking subject. Like, they'll say, hey, this bounced out of 10.100 to 8.152, and great, thanks, RSA.
Okay, so if the network is the toast, applications are the butter. This is about application discovery. Every application that your target is running is a potential entry point, whether it's commercial applications they purchased, things they've written in-house. So finding these applications is the trick. A lot of times, you're not going to get some high-profile, Windows remote exploit. You're going to go after an application. So another point to this is slow and steady wins the deface. A lot of times people will scan, large blocks of IP addresses, every port, and that's really noisy. We like to do stuff like, for example, that command up there is an nmap command that says, don't ping the target, scan for a specific port, in this case the MS-SQL port. This gives you a ton of information without making a ton of noise. And what does it tell you? It tells you most likely what the operating system of the target is. If it's running MS-SQL, it's probably Windows of some sort. It tells you that they're running MS-SQL and that they're available. So, think a little bit different. A lot of people will assume, oh, every attack's going to begin with a full-on nmap port scan. And that's not necessarily true. IDSs will detect that, try to avoid it by doing slow, targeted, one-shot, one-kill type attacks. So one good example of this is one of the targets we were working on had an internal application for doing software licensing and distribution. They'd written this in-house. It was installed on something like 10,000 computers at this company. We spent a couple of hours, we got a copy of this, spent a couple hours with IDA, Ollie Debug, checking it out. And it turns out they had a static admin password hard-coded in this application. So every host on the network used the same admin password to get their software and their licenses. This means every accessible node was owned. We didn't use a single exploit. It was just targeting the application. Do you want to switch, please?
All right, so who's heard of W3AF? Okay, a few folks. Great. So kind of what I'm trying to do with this talk and with some of the parts of the talk is talk about tools that are really great that a lot of folks don't really know about yet. And W3AF is a good example of that. It stands for the Web Application Attack and Audit Framework. It's this neat little read-line enabled shell, and you can actually do all these cool things like brute force vhost, brute force directory structures, brute force names, all these things you normally want to do with websites that you normally have to use an external tool for. But you can do it all from this quick little console, and it's easy to use. I mean, it's kind of like Metasploit, so I like it in terms of how the console works. So I've been calling it, Metasploit for the web, but unfortunately it's written in Python. Outside of that, I love it. And I'm sure he feels the same way about Metasploit being written in Ruby. So we get along on that. Finally, there's actually a whole new set of classes in Metasploit 3 for writing your own quick vulnerability scanners. If you want to write a vulnerability scanner that connects to every host on a certain port, sends some data to it, receives data from it, does something to it, that takes about 5 minutes in Metasploit 3. You can find examples of that under modules, auxiliary scanner. We've got one that gets the version of every box running with SMB open, like 139, 445. We've got another version that'll go through and find the web server version for every host in the local network. Another one that actually mass defaces every host in the local network via put request. So it's whatever you want it to be. But if you're going through the same steps over and over again of writing something that parses the CIDR mask, does connections, does error handling, and all you're really doing is connecting to a service and doing a probe, you can do that in about 3 lines of code with the Metasploit 3 mix in modules and templates. So keep that in mind if you're writing your own stuff. It's really good if you find a custom application or an evil misconfiguration on a customer network and you want to find out what other system that applies to. So let's say a default password for a web interface. Say, okay, well they've got it set to this here. I want to make sure it's not the same password set for every other node. And it has threading support. So you can set the number of threads to be like 1,000 or 256 and kick off that many hosts at the same time. And the whole thing's kind of done for you and reporting is all nice and whatnot. So just keep that in mind if you're doing your own application discovery. The next step is client app discovery. And this is a little bit trickier because you can't the clients have to connect to you for you to get that information. However, client apps are so vulnerable that they're definitely a good target, and a lot of folks aren't actually trying to do profiling of client applications during a pen test. And they're really easy to fingerprint, but you have to get them to do something. Client apps really are your last chance entrance. If you can't do anything else, you should be able to at least exploit a random client. And the reason for that is, the admin can really focus his time on a couple servers to lock them down, but he really can't focus his time on 10,000 users or 50,000 users or even 30 users. So there's lots of different probe methods you can use to profile client applications. The most obvious one is use mail a link to a website to every client. Abuse the all at and everyone at and team aliases. So if you know the company does software, try emailing SWT at, try emailing everyone at, all at. These folks get so much spam that even if they see a weird email come in, it's not going to raise that many flags, especially if you make it look like a Viagra spam, something like that. You can also do things like send a message disposition notification emails. There's things that, when you get an email and it pops up saying, the sender requested that you notify when you receive this. There's really, really annoying things that just about everyone here probably ignores. There's actually a huge swarm of corporate clients out there that will auto-respond to these. So just because you're smart enough not to enable that stuff doesn't mean they are. So definitely give a shot with those as well. And finally, once you figure out the NAT gateway of your target, try searching just via Google or anything else for the external IP address. A lot of times what you'll find is that IP address will end up in exposed web logs. So you can find out not only what types of browsers they use, but whether or not they like goat porn. I mean, anything. You can find out what sites they visit based on that. Finally, so this is actually a technique and a kind of a process that a lot of folks really don't do, is when you're focusing, when you're doing a pen test and you're trying to focus on specific servers, IPs, versions, software, what you don't look for is whether or not certain activities occur. Like, for instance, how many times have you seen a completely locked down network, but then when you go into the network, you'll see they're doing, an anonymous FTP transfer to an external host every night at a certain time. I mean, that kind of stuff it's a huge weakness, but at the same time, it's not something you can only look for. So what I'm going to talk about are a couple ways you can actually look for this type of activity, actually identify the processes being used to actually attack those protocols and attack those types of weaknesses. Good examples that are looking for large IP ID increments in the middle of the night. So who is familiar with IP ID scanning? Great, a lot of you guys. The general premise is that a lot of different hosts, each time they send a packet, they'll increment their IP ID counter, and that'll wrap after 64K and so on. But if you ping that host and see the IP ID coming back, and then ping it again, if you do the delta between those two IP IDs on a host that supports this type of incremental IP ID, you can determine how many packets are sent between those two pings. So you can do all kinds of great things. You can basically do a remote traffic monitor of any host you want through this method. Additionally, a lot of FTP servers, and especially Microsoft FTP, they support a command called site stats. And what this will return is the number of times each command has been executed on that server. And this gives you a great amount of information because you can determine when uploads are being done, when deletes are being done, when people log into the server. You can start getting a feeling for, okay, if I want to start hijacking data ports, what's the time to start scanning for it? And finally, you can actually look for the last modified header on static content on websites to figure out when they do automated transfers or automated backups. A couple cases I've seen, people will actually delete the entire web directory before they sync it over each time. So you have about 30-second to 1-minute window where things like the .htaccess file aren't there, where there's a directory index listing because they deleted indexed HTML. So basically, by going through the web root, and this doesn't work for dynamic content, and doing basically a head request against each image in the directory, compare all those timestamps. See if they're all within a second or two of each other, or see if they're a few seconds apart or a minute or two apart. Now try it again the next day, the next day, the next day over a week-long period. What you may find out is they're actually doing a full backup or a full upload every night at a certain time. Now you know when you want to start getting that site as fast as you can, trying to find a window where the htaccess isn't there or it's otherwise misconfigured. So are there any existing tools for this stuff? Not that I've seen. Correct me if you have seen some in the Q&A session, hopefully. I just tend to use hping, pipe to a log file basically, or netcat, or any other tool for the site stats stuff. Here's an example of the site stats command running on ftp.microsoft.com, and this is just one of many, many nodes inside their FTP cluster. Something to keep in mind is this node's only been up for 47 days, and it's had over 2 billion user commands. So they get a lot of FTP traffic. However, they've had 2 billion users do the user command, but they've only had 3,035 store commands. So if you basically profile the number of times a store command has been run over a period of time, you can determine when they're actually doing their uploads. And when they're doing their uploads, you know you can actually interfere with that by hijacking the data port. And I'll talk about hijacking data ports and that stuff a little bit later on. The point of that is, even if you can't steal their file, you can still destroy their backups. And you see some other commands like delete, make directory, etc. The next example is a website called hacker.com, which I picked right before Black Hat because it was fun. I started profiling this site around 8 p.m. and I stopped it around like 6 a.m. or something like that, or probably 10 p.m. is when it started. So this is basically the delta between the IP ID increments accounted for the integer wrap across about a 9-hour period, something like that, 9 or 10 hours. So around 10 p.m. you can see it spikes to about 3,000, but the baseline traffic is pretty low. As I get right around midnight, you see a huge spike in traffic. This is actually some kind of automated backup process, or somebody just Wing the crap out of that site right around midnight. This is the kind of thing you want to look for. If you're profiling a server and you want to find out when they're doing large backups, when they have some kind of data recovery routine running, this is how you can do so. You can also find other types of activity through this method and be like, hey, something really big happens at this time. Let me know what that is. And this little graph was actually generated with a little like one line of Ruby in like 5 minutes. So if you want to know how to do it, let me know after the talk and I can show you the code for it. Then you see the traffic kind of lulls down for about 6-7 hours. And finally you can see everyone in the US starts to wake up again and the traffic builds back up. So if you're curious how much traffic a site has and their server does sequential IP ID increments, this is a great way to do it. What you may see sometimes is that you get 2 or 3 sets of IP IDs back. In that case, you're actually hitting a load balancer. So, one server will respond back with, 1,000, 1,001, 1,002. Another one's 9,001, 9,002. And you have to kind of keep track of both of those at the same time. So on to the external network. That was kind of our discovery techniques or discovery phase. Just different techniques to keep in mind when doing a pen test to profile services, find users, find networks, find applications, just some quick tips. The next section is all about actually breaking in. The first thing we're talking about is external network, and we'll work our way inside. On the external side, usually called the crunchy candy shell or whatever you want to call it, what the administrator usually thinks they're exposing are the host they specify, this web server, this mail server, this application server. What they're really exposing is all those things, plus their VPN services, plus their proxy services, and plus all those different client-initiated sessions. A lot of folks don't realize that the public NTP servers, if you send a command called monlist to them, they'll come back with a listing of every IP address, every client that's actually connected to them within a certain window of time. And there's only a finite number of public NTP servers. So what you can do is build code that basically goes out and pings each one of these servers with this monlist command every 5 minutes, and not only do you find out when a given organization is querying the public NTP servers, how many different clients are querying it, and whether or not those clients are behind or inside or outside of the firewall. You can tell that by looking at the source port. NAT gateways will translate that from the normal source port, which is 123, to something else, and it also gives you a window where if you send a spoof packet from that time server to that host on that source port, you'll get back to that time client. And now you can actually start doing attacks against those NTP clients themselves. So any case where you can see the outbound UDP traffic and see those source ports, you now know what the NAT gateway mapping is, and you can actually target those applications. So I mentioned FTP before. I'm sure, does everyone here know how FTP works? All right, you realize there's 2 connections. There's control, there's data. The data port's kind of allocated based on either the server or the client. Active FTP, the client opens up a listener for that. And passive FTP, the server opens up a listener and the client connects to it. So that's basically it. Going through a NAT gateway, there's all sorts of problems with active FTP. I'm not going to talk about them too much, but if you see large spikes in traffic, try scanning for the ports used by the NAT gateway, like 32K to 45K, or even 1024 to 64K, just repeatedly, trying to find those open ports. A lot of times there's different vulnerabilities with how NAT gateways handle active FTP, and I'm not going to get into those here, but just keep those in mind when we're doing this kind of testing. Finally, passive FTP. This is much more common. This means the server opens up a port and the client connects to that server. If you can also connect to that server, log in as like anonymous, or you just port scan the crap out of it, you can actually predict the ports that are being used in a lot of cases. Microsoft FTP is a really good example of this. Their FTP server will sequentially allocate those data ports no matter what client it is. So if you connect FTP to Microsoft.com and you send the passive command, it'll come back saying, oh, port 100. The next client who's doing it will get port 101. The next client will get 102. And the Microsoft FTP is smart enough that if you connect to that data port instead of being the real client, it'll kick you off. It'll say, sorry, I'm not going to send you that data. That wasn't your data port. However, you'll still break the backup. You'll still break that transfer. So what you can do is if you profile a backup process running in the middle of the night and you know what endpoints are, you can find these data ports and you can steal the data ports before the client can get them. And in doing so, you can break their disaster recovery system. There's a tool I wrote for this called passiveag.pl. It's been around for a really long time, but it still works really well for this type of thing. So finally, moving on to attacking web servers. One thing, just don't ever make sure when you're doing an assessment against a website, you always check for things like /old, /backup, /admin. This should be old hat, but you can find all kinds of really cool things with it. Example, Cray.com for like the last 5 years has had this directory called /old. And until about a year and a half ago, it actually had directory indexing enabled. Inside the directory was a 5 gig file called backup.tar. And any guess what that was? All right. So they finally made the directory for, excuse me, the disabled directory